Okay, example 8. A force of magnitude 800 Newton caused an extension of 20 centimeter on a spring. Determine the elastic potential energy. Elastic potential energy is U, spring. And then, determine the elastic potential energy when the extension is 30 centimeter and when a mass of 60 kilogram is suspended vertically from the spring. Okay, so we have force 800 Newton as well as the extension 0.2 meter. Now we have to find the elastic potential energy. Okay, so the first question A, we have the Hooke's law, F is equal to Kx. Kan? So from here, we have to find the spring constant dulu. So F over X. Because the formula for elastic potential energy is equal to half Kx square. So the spring constant K here is not given in the question. So we have to find the value of K dulu. So value of K is calculated using this formula. So 800 divide 0.2 will then get the value 4 times 10 to the power of 3 Newton per meter. Okay. Now, just substitute this value. X is 0.3 square. So you'll then get the elastic potential energy to be equal to 180 joules. Okay. So for this one, the spring constant, nama dia pun constant kan? If the extension keeps on changing, the spring constant K here will be constant lah. Okay. So that's why we can find the value of K using just the information here. Okay. Alright, next question B. When ada mass of 60 kilogram suspended vertically. So assuming this is our spring, and then this one is when dia ada 60 kilogram punya something here, 60 kilogram. Okay. Then we have to find the elastic potential energy lah. Okay, so because of that mass, it has extended berapa banyak? We don't have the value. This is X lah. We don't have the value. So, but we do have K. So let's do that. We can then use the formula. F. The net force is equal to 0. Okay, so the net force is equal to 0 because there is no movement. There's just an extension. So Fs would then equal to mg. Okay, so what I am doing here is, if we were to draw a free body diagram, this is the mass, and then this is the spring restoring force, the tendency of it going back to its original extension, original spring. Okay, so if we write, let me just redo that. So basically Fs will be minus mg equal to 0. So we have the restoring force to be equal to mg lah. Okay, and then we know that restoring force is equal to Kx equal to mg here. So then from here we can then get the extension of the spring, which is 0.147 meter. Okay, and then from here baru kita boleh cari the elastic potential energy lah, Kx square, sebab baru kita dapat the value of X lah. Okay, so X is 0.147 square. Then you'll get the elastic potential energy to be equal to 43.2 joules. Alright. So basically this one, restoring force ni, it goes from the object towards the spring punya original position lah. Okay. Right, so that is example number 8.